In level 2, we will be evaluating trig functions for angles on the unit circle, and we need to know the unit circle really well. So our big goal is to memorize the unit circle and to be able to evaluate trig functions very quickly. So let's start by filling out the unit circle. We always start on the right side with 0, a 0-degree angle, and that's also 0 radians. And the unit circle has a radius of 1. So every radius in this circle is 1. That makes the coordinates of this point right here 1, 0. The next part will go 180 degrees around, which is equivalent to pi. And the coordinates of that point would be -1, 0. Now, halfway between 0 degrees and 180 degrees is 90 degrees. And halfway between 0 and pi radians is pi over 2. And the coordinates of this point would be 0, 1. And then our other quadrantal angle, if we add 90 degrees to 180, we get 270. And with our pi over 2's, if the top part is pi over 2, over here would be 2 pi over 2. This makes 3 pi over 2. And the coordinates of that point would be 0, -1. Next let's do our pi over 3's. So if we divide the top semicircle into thirds, we would get 3 pieces of pi like this. And we could also divide the bottom semicircle into thirds. And these would be our pi over 3's. So this first one is 1 pi over 3. This is 2 pi over 3. And then right here we would have 3 pi over 3, which simplifies to pi. So I don't need to keep that one. I keep going and I get 4 pi over 3, 5 pi over 3, and then this would be 6 pi over 3, but that reduces to 2 pi. And all of those angle measures in degrees would be, this is a 60-degree angle, 120. Next we have 180, add another 60 degrees to that, we get 240. Add 60 to that, we get 300. Add another 60, and we're at a full circle, 360 degrees. Next, I will look at dividing the circle into my pi over 6's. So if I look at my top semicircle and divide it into 6 parts, I get a division here, 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 here. And that gives me 6 pieces. So my first part is going to be pi over 6. My next one would be 2 pi over 6, which reduces to pi over 3, and we already labeled that, so we don't need to keep that. Next, I would get at the top 3 pi over 6, which reduces to pi over 2. 4 pi over 6 reduces to 2 pi over 3, and then finally we get 5 pi over 6 right here. Next I would get 6 pi over 6, which reduces to pi, so we don't keep that. And then comes 7 pi over 6. 8 pi over 6 reduces to 4 pi over 3. 9 pi over 6 reduces to 3 pi over 2. And then we get 10 pi over 6, which is 5 pi over 3. And then finally right here we get 11 pi over 6. And then next would be 12 pi over 6, which reduces to 2 pi, our full circle. And the angle measures for these are 30 degrees, and right in between 120 and 180 is 150 degrees. Between 180 and 240 we get 210. Between 300 and 360 is 330. And then finally we want to divide our triangle into our pi over 4s. So that's here, here, here. That's dividing the top semicircle into fourths. So the first one is pi over 4. Next we would get 2 pi over 4, which simplifies to pi over 2. And then we get 3 pi over 4. 4 pi over 4 simplifies to pi. Next comes 5 pi over 4. 6 pi over 4 simplifies to 3 pi over 2, and then comes 7 pi over 4. And then 8 pi over 4 is 2 pi, our full circle. In degrees, right in the middle of 0 and 90 is 45-degree angle. Between 90 and 180 is 135. Between 180 and 270 is 225. Between 270 and 360 is 315. And then the next thing we need to know are the coordinates of each of these points. Our 30-degree angle, or our pi over 6, has the coordinates radical 3 over 2 for the x, and then 1/2 for y. At pi over 4, it's radical 2 over 2, radical 2 over 2. So both x and y are the same. At pi over 3, or 60 degrees, we take the coordinates from pi over 6 and switch the x and y. So the x, which is shorter this time, is 1/2. The y is radical 3 over 2. And then in all the other quadrants, it's going to be the same points, but with different signs. So in quadrant 2, we have negative x values. So it's going to be negative 1/2, but still positive y's, radical, so this will be radical 3 over 2. So same point we had for our 60-degree angle. And then for 3 pi over 4, it's going to be a negative x value, so negative radical 2 over 2, but positive y value. And then at 5 pi over 6, again, a negative x value in quadrant 2, so negative radical 3 over 2, but a positive y, positive 1/2. In quadrant 3, we're going to have the same points, but they're all going to be negative because both x and y coordinates are negative in quadrant 3. So we get negative radical 3 over 2, negative 1/2, negative radical 2 over 2, negative radical 2 over 2, and negative 1/2, negative radical 3 over 2. And then in quadrant 4, we have positive x values and negative y values. So we get positive 1/2, negative radical 3 over 2, positive radical 2 over 2, negative radical 2 over 2, and positive radical 3 over 2, negative 1/2. And that is the unit circle. The most important part of level 2 is going to be evaluating trig functions and knowing the unit circle so well that you can do it quickly. So remember with our 6 trig functions, sine of theta, or any angle theta, is always y over r. Cosine of theta is x over r. And tangent theta is y over x. Cosecant theta is the reciprocal of sine, so we get r over y. Secant theta is the reciprocal of cosine, r over x. And cotangent is the reciprocal of tangent, x over y. But remember that in the unit circle in particular, r is always 1. So every radius in this circle is 1. So every one of these r's is now, when we're talking about the unit circle, it's going to be 1. So now sine theta is just going to be y over 1, which is just the y value. And cosine theta, x over 1, is just going to be the x value. Tangent theta is still going to be y over x. Cosecant theta is just going to be 1 over y. Secant theta is going to be 1 over x. And then cotangent theta will still be x over y. So this is when we're talking specifically about the unit circle where the radius is always 1. Now, to find cosine of 135, our first example, first I'm going to think in my memory about where 135 is. That's right here. And I'm going to find, for cosine, I'm going to find the x-coordinate. So we get negative radical 2 over 2. For cotangent of pi, we're looking right here, I'm going to find the x over the y. The x is negative 1, the y is 0, and this is undefined. Remember, we can't divide by 0. For tangent of 5 pi over 6, we're going to do y over x. Here's 5 pi over 6. The y is 1/2. The x is negative radical 3 over 2. And to divide these, remember when you divide fractions, you multiply by the reciprocal. So this is 1/2 times the reciprocal of negative radical 3 over 2, which is negative 2 over radical 3. And those 2's cancel. We get negative 1 over radical 3, but I need to rationalize that. I can't leave the radical in the denominator. Multiplying by radical 3 over radical 3, we get negative root 3 over 3. And the more we practice these, we start to memorize some of these nuances and specific ones, so we can do this quickly. Cosecant of 9 pi over 4. 9 pi over 4 is not specifically one of our angles on the unit circle, but remember that 8 pi over 4 is a full circle, so that's one more pi over 4 past that. This angle is coterminal with pi over 4. So cosecant of that angle is going to be 1 over the y value, or 1 over radical 2 over 2. That's the reciprocal of radical 2 over 2, or 2 over radical 2. But again, we can't leave the radical in the denominator, so we multiply by radical 2 over radical 2, and we get 2 root 2 over 2, and these 2's cancel. We just end up with radical 2. And for the next one, we'll first find secant of 7 pi over 3. 7 pi over 3 is not labeled on the unit circle, but remember that 6 pi over 3 would be a full circle, and we go another pi over 3, that makes an angle coterminal with pi over 3. Secant of that angle is 1 over x. 1 over 1/2 would be 2. So we're going to get 2 times, and then we need to find tangent of negative 5 pi over 3. If we swung down, or sorry, negative 5 pi over 4, negative 5 pi over 4 would be coterminal with 3 pi over 4. So tangent of that angle would be y over x, radical 2 over 2, divided by negative radical 2 over 2, which is negative 1. So we get 2 times negative 1, which is negative 2. And then for the last problem, we need to find secant squared of 7 pi over 4. First we would find secant of 7 pi over 4. And 7 pi over 4 is right here. Secant is secant of 7 pi over 4 is 1 over x. So we get 1 over radical 2 over 2, which is 2 over radical 2, and multiply by radical 2 over radical 2, we just get radical 2. So secant squared of 7 pi over 4 is just squaring that, which comes out to 2. And then tangent of pi over 4, since the x and y coordinates are the same, is just going to be 1. So this problem will be 2 divided by 1, or just 2.